Hi, today is 4th July and from today exactly 146 days is remaining for the CAT 2020. So I'm going to discuss two questions from the geometry, basically the coordinate geometry. So you can see one of the question was asked in IMC 2001 for their program PGDCM, and the same question was repeated in CAT 2005 with a little bit change here. Alright. So you all can take some time. Let's take around 2 to 3 minutes or maybe 5 minutes. Try to solve both the questions, and if you're not able to get the answers, then you can see the explanation. Okay, now just here. The first question says, for what values of alpha will the following system of simultaneous equation have exactly three solutions? So here we need exactly three solutions. And the second question here, we need a unique solution for x and such that the solution is positive. So in both the cases you can easily observe that both the equations are same here. Okay, in one of the cases we need to find out the values of alpha for three solution, exactly three. In the second we need a unique solution and that solution has to be positive here. Alright. Now you can solve it algebraically also, but algebraically if you try to solve it, it might be time consuming. So if you use it, if you try to solve it by using coordinate geometry funda, it can be solved quickly. Now just here how. It says, for what value of alpha will the following system of simultaneous equation have exactly three solutions? So we need to find out if the condition on alpha for exactly three solutions. Alright. Now first equation is x square minus y square. Alright. If you look at here, first equation is x square minus y square. So let's try to solve this particular equation here. So when I say that is x square minus y square, it is equal to 0. So this implies what? That is y square, it is equal to x square. And further we can say that this is nothing but that is y is equal to plus minus x. So basically this is the equation of a line. Okay, this is equation of a line. There are two lines, y is equal to plus x and y equal to minus x. Now if you look at the second equation, okay, this is nothing but this is what? Equation of circle. Alright. So this is the equation of circle. And what is the center of the circle? The center of this circle, here we can say, the center of this circle is nothing but that is alpha comma 0. And what is the radius of this circle? The radius of this circle is nothing but that is 1. It's a standard form, x minus a whole square plus y minus b whole square is equal to r square. And here r is 1 here. So there are two equations, one of them is line and the other one is circle here. So let's plot the graph here. So this is the x-axis and y-axis. Now we need to first of all plot the graph of y equal to plus x and y equal to minus x. So let's say this is the line. So this line is what? This is the line y equal to plus x. Alright. And then another line I can draw, that is y equal to minus x. Alright. So there are y equal to minus x here. Or let me write it down neatly. So y is equal to minus x. Now I need to draw a circle. Drawing a circle whose center is what? Alpha and 0 and the radius is 1. So center is alpha and 0 means what? Center is lying on the x-axis. So it means center is lying on the x-axis as its y coordinate is 0. So I am drawing a circle. So this is a circle with the radius 1 unit. And we know that the center of this circle here, I can say the center of this circle, it is nothing but it is alpha comma 0, which means this circle will lies on where? It will lies on x-axis. And what is the condition here? The condition is that we need exactly three solutions. So where should I draw the circle? Where should this center lies on the x-axis? Such that this equation has exactly three solutions. So we can see it here. Alright. So let's see it here. Okay. Now, so you can see this is the graph here. So if this is a circle, now if I say this is the circle is like this one. Okay, you can see the center. Now under this condition, when this circle is like this one, what is the solution? There is no solution. We need to check this circle, it cuts the other lines, y equal to plus minus x at how many points? Still there is no case. Now if you look at here, I'm just slowly moving the circles and you can see it here like this. Now, if you look at here under this condition, so under this condition, what is happening here? Okay, under this condition, what is happening here? So you can see here that under this condition, this has got how many solutions? Here, if I mark it here, this is cutting the x-axis at this point, and this is, sorry, line equal to y equal to x and y equal to minus x. So in this case, you can see there are exactly two solutions. Okay, there are exactly two solutions. But there are several other possibilities. There can be a case where there is four solutions, like if I draw a circle like this one. You can see it here. There are four solutions. Why? Because it is cutting the circle at 4 points. This is 1, 2, and 3, and 4. So there can be two solutions, three solutions, four solutions, no solutions. There are a lot of possibilities. So the same question can be asked in different ways. What should be the value of alpha such that there are two solutions, three solutions, four solutions, or no solutions? And that is the homework for you that you should try. Now, but here we need to find out for the three solutions. So let's do it here for three solutions. So can I say for three solution, my circle will be exactly like this? Okay, you all can see it here. This is how our circle will looks like here. So it is cutting the graph at how many points? It is cutting the graph at exactly 3 points. What are those 3 points? I can say this is 1 point. This is the another point 2, and this is another point, that is 3. So we are getting exactly 3 solutions if I draw a circle like this one. Okay. So now for this figure to exist, I need to find out where does the center of the circle lie. Okay. So we'll see how to calculate the center of the circle here. Alright. So you can see like this one. So I need to calculate the center of the circle. Let's say this is the center. Now we know that the radius of this circle is 1. So if the radius of this circle is 1, what does it mean? If the radius of this circle is 1, that we already know. So this distance, it is nothing but I am going to highlight this distance, which is I am marking red. It is nothing but radius, and this is my radius. And what is this radius? Radius is equal to 1 unit. And this is the center of the circle also, that is known as alpha, 0. So what is the value of alpha? Alpha is equal to plus 1. So we have got that alpha should be equal to plus 1. Similarly, the same circle, I can draw it on the other side like here also, like this. And here it will be alpha will be equal to what? Minus 1, because again the radius is equal to 1. So this is 1 unit, but it is on the left hand side of x-axis or left hand side of the origin. So I can say this is minus 1. So there are two possible values of alpha. It can be equal to plus 1 or minus 1. In both the cases, we'll be getting exactly 3 solutions. Like in the second case, these are the 3 solutions here. So in both the cases, we'll be getting exactly 3 solutions. Similarly, you can even find out under what conditions it can have 4 solutions, or what is the range of alpha in which this equation can have 4 solutions or maybe 2 solutions. Okay. Try to find it out, and you can post in the comment section, and I can confirm whether your answers are correct or not. Now, let's move to the next question. Again, the same thing. It says for which value of k does the pair of equation yield a unique solution? We need a unique solution. For x, there is a unique solution for x. So for x, there is a unique solution such that the solution is positive here. Okay, such that the solution is also positive. So we need a unique value of x, and at that value of x, the value of y should be also positive. Okay, that has to be positive. Both x and y should be positive here. Now, just see here. So again, I'll say first I'll plot the line x equal to y equal to x and y equal to minus x, as we have discussed in the previous question. This equation will give us y equal to plus minus x. Now, this is again a circle. Here the center of the circle is k and what? That is 0. So, k and 0. And the radius of this circle, it is equal to 1. That we know. But we need the solutions to be positive and unique. That is the condition. Okay. We need the solutions to be positive and unique. So, now, this is the circle that you all can see it here. So, if I draw this circle like this one, remember it has to be positive. X is positive. So can I say there is a unique solution for x? So you can see under this condition we are getting, when my figure it is touching the lines, we are getting a unique solutions. You can see it here at this point. X is positive, so there is only one value of x, And I also need y to be positive. So this is the point here. Okay. And I can say that this value of x, at this point center, it is positive. So at this point, whatever this point is there, it is in the first quadrant. So both x and y are positive here. And there is a unique value of x. Okay. For there is a unique value of x here. So I hope that it is clear to all of you. So we do not need to take the negative values here. Okay, we do not need to take the negative values like this one here. Okay, so now let's see it here. Okay, all right. So you can see the figure now. This is the figure here. So I'll say this is my center of a circle. And this center, it is nothing but that is k comma 0. And we know that the radius of this circle is 1. So I'll draw this line. And this angle is 90 degree tangent to a circle. So it is 90 degrees. So this radius is nothing but that is 1. So I can say this point is equal to 1. Okay, this is 90. Now this is a 90-degree angle here. Okay, and this angle is nothing but 45 and 45. So if I say this is a triangle PQR. Okay, PQR. So basically we have got a one triangle like this. Okay, and this angle is 90 degree, this angle is 45 degree, and this angle is 45 degree. So it's an isosceles triangle. And this is P, this is Q, and this is R. So PQR, the length of PR, it is 1, which is basically the radius of the circle. And we know that the radius of the circle is 1 unit. So PR is equal to PQ, so I can write down this as also 1 unit. And since it's a right angle triangle, so what is the length of QR? Hypotenuse, it is root 2. By using the Pythagoras theorem, I can say root of 1 square plus 1 square. So QR is equal to root 2. And what is QR? The length QR, it is also equal to K. You can see it here. I can highlight this distance, it is equal to K on the x-axis. So QR is equal to K, so K is equal to root 2. So the correct answer of this question is option number C. So I can say the answer is option number C, which is equal to root 2. So I hope that this question is clear, both the questions. So if you know the basic of geometry and the coordinate geometry, like equation of circle, okay, and the equation of line, then this question can be solved quickly. There are other algebraic approach also, but that might be a time consuming here. Okay, you will get inequalities, you need to solve those inequalities here. So that's all for today. And we have also started our free webinar, and in the coming weeks or coming days, we are going to discuss a lot of questions. Okay, so you all can join our WhatsApp group and the Telegram group to get the information about all those upcoming free webinars. Thank you.